All right, hi guys. Today I want to show you a little video of something I've discovered that is leaving me perplexed and confused that I can't explain. So this is part of my work for the Canadian Space Agency in collaboration with the Indian Space Research Organization. If you're not aware, I have helped develop the detector and the detector electronics for a space telescope that's in space right now, and it detects ultraviolet wavelengths. It's an ultraviolet space telescope. It has to go in space above the atmosphere, of course, because the atmosphere blocks a lot of ultraviolet. You can't do ultraviolet astronomy from the ground. You have to go up in space to do it, to get those really deep, those far ultraviolet wavelengths. So in any case, that telescope was launched in 2015. Before that, I'd been, helping with the ground development, ground testing, all that sort of good stuff, ground engineering. Ground support it's called. So it launched in 2015. Now I'm doing data reduction, data analysis for this telescope. And so I have reduced, probably hundreds or thousands even by now, thousands of observation sets for this telescope at this point. So I'm very, very familiar with what to look at. This image we're looking at here is what's called a visible channel tracking image. This telescope has to track itself, and it does that in the visible channel. Just think of it as a guide star pointing. So it uses a visible channel, a visible wavelength, as opposed to ultraviolet, a visible wavelength channel for guide star tracking. So that's what this image is that you're seeing right here. These are visible wavelength stars. And then there's the far UV telescope, the ultraviolet wavelength telescope that we actually do the science with. So this visible channel is used for tracking. So in any case, I've, reduced thousands of sets of observations from this telescope, and I know what, I'm very familiar with what you see. And so, for example, let's scan through these images. And so what do you people watching, what do you fellows think that these objects are streaking through the image? I'm going to pause it and think about it. If you just want to let me tell you, go ahead. Let's continue. Um, so I've seen lots of these. There's many, many examples of this phenomenon. I've seen it hundreds of times, and the first time I saw it, it never bothered me, and it's never bothered me, and it's totally what I would expect to see in cases where another satellite passes in front of view of our telescope, because our telescope is at 500 kilometers altitude, which is not too high, actually. There's lots of satellites that are slightly higher than that. And so when you see an object going through the field of view, now this field of view is half a degree, by the way. So this is a half a degree field of view, half a degree across. So it's not that large a field of view. What is that about? What is the moon? Is the moon half a degree? Boy, as an astronomer, I should know that. It's probably maybe the moon is anyway. This is a half a degree. Someone can look up what the moon actually is, then you can compare. In any case, so this half degree field of view. So these to me have never bothered me because these are simply other satellites passing in front of you of the telescope. You can see that they go in a very straight line with a bit of a streak because they're moving very fast. The images on this visible channel tracker are 1 second integrations. So it exposes for 1 second and then resets and exposes again for 1 second. So in 1 second, a very quickly moving satellite, because obviously all the motions up there of satellites are very, very fast, going, several kilometers a second, I think. So you would expect to see a streak like this, and they're going in a very, very straight line, right? So that's totally normal, never bothered me. So now look at this, what I just saw in one of the most recent data sets that I reduced. Something very, very interesting. I think this is the correct one. Look at this object. Look at how it curves. And look at this one. So there's 3 examples. Look at this one curving, and look at this one. Not only curves, it's curving with an acceleration. So these first 3 examples, they're moving in a curve that's basically a constant curve. It looks more or less constant, a constant circle. This one is undergoing some sort of acceleration, some sort of powered acceleration, because the curve that it's moving upon isn't just constant like you would expect from a circle. It's more like a hook, which is what you get from which is what you would get from powered acceleration, from accelerated movement under acceleration, under power. So I have no idea what in space, in low Earth orbit, could cause motion like this. I have no idea. Those other ones that we saw, that's fine. Straight line motion, those are obviously satellites from those other ones. These ones, this is the first time I've ever witnessed anything like this in reducing thousands of observations. It's the first time I've ever seen motion like this, and I have been just really perplexed as to what could cause motion like this. That's not motion you would expect of any satellite in space. I really just don't get it. Maybe it's a UFO? I mean, obviously I'm just being funny, but maybe. I really can't explain what this is. I don't know, maybe I'll go around asking some people. You can say what these are. I'm just really confused. I just sit here and I watch this over and over again, and I'm trying to think. I'm racking my brain cells together, trying to figure out what could cause motion like this from another object in space. I really can't explain it. That's not what an asteroid would do. It's not what another satellite would do. Even if it was like a rocket in space, I mean, there wouldn't be rockets in space because we're at 500 kilometers altitude. There isn't this many rockets out in space where we would be looking. And then you would probably see a plume or some other shape. I mean, there's no rockets out in space in any case that we know of. Not this many, like an Elon Musk rocket or something like that. I mean, given that they're moving on curves, it looks like, I mean, that has to be powered movement. It has to be propulsed movement because nothing, I just can't think of anything that should give movement on a curve like this. That can only come as a product of acceleration. If it's a product of acceleration, that means it's a product of powered flight. But what would be doing that? Because satellites don't move like that. Asteroids don't move like that. I really can't explain it. So here, I'm changing the scan time to 1 second because that's what was actually seen. It's 1 second integration times. I just put this down to 0 seconds between frames just so that I can see them quickly. Yeah, this is my favorite one. This is my favorite one just because it really, really exhibits accelerated motion. It's not merely motion on a constant curve, which itself smacks of accelerated motion, or motion under acceleration under power, but this one, the curve is changing. Yeah, so that really, this one really, really smacks of movement under power. Anyway, if anybody can think of what they are, let me know. I'll have to pass this around to a few people. Get some ideas because I really can't think of what it could be. All right, hope you enjoyed that. Hope you're all having a good day. Bye-bye.